course, we're not doing too bad on time, so we're going to go ahead and continue to press with our schedule. And if we have time, we've got a little bit that we want to show you as well. But our next speaker is Steve Cook. Is Steve here? Is Steve ready to go? Oh, there he is, off from the lights. So Steve Cook is joining us from Dynetics. He's the Director of Space Technologies. He was selected for this position in 2009. He's responsible for leading all of Dynetics' efforts in launch systems, orbital spacecraft analysis, and planetary exploration. From September 2005 until September of 2009, Steve served as the manager of the Ares Program Office at NASA's Marshall Space Flight Center in Huntsville. He was responsible for overall project management and direction of NASA's Ares 1 and Ares 5 launch vehicles. Prior to his appointments as manager of the Ares Project Office, he served as deputy manager of Marshall's Space Transportation Programs and Projects Office. He's also responsible for planning and directing research, technology developments, and activities for future generations of space transportation and advanced propulsion systems for more ambitious scientific exploration missions of our solar system. And Dynetics is a really cool company. They're doing some very interesting things. And I'll let Steve tell you about them, but there's one in particular that I think that this crowd may find very interesting. So without further delay, Steve, can you join us?
Well, good morning, Paul. Thank you very, very much. And Paul, congratulations on your appointment. And I know you will do an excellent job. And we're looking forward to years of your leadership of the National Space Society. If I could have my charts up on the screen, please. And by the way, as cool as I tell you, I'd rather sit in the audience and watch the ISS feed than listen to me talk on the way to lunch. But you just have to put up with it as we go there. What a great morning we've had. First off, let me obviously add my congratulations to the SpaceX team. Clearly had a great launch and a grappling maneuver and on to a successful mission. Clearly the COTS program that was started under the Bush administration is now starting to take flourish under this administration. And I want to congratulate the hard work of the NASA team and their investment and the SpaceX team and their hard work and endeavor into this. This is a tough business. There's no such thing as easy access to space. And so today is clearly a big day in our business. I also want to thank and congratulate our Canadian friends, our Canucks. Any Canadians in the audience? All right. Well, congrats on the grapple, because if that hadn't been there, you know, Canada has spent decades investing in robotic arm technology at the encouragement of the U.S. And the fact that arm was able to grab it this morning was key to the success of this mission. Let me also thank Mark Sarangelo, the previous speaker. I don't know Mark all that well. We've kind of passed by each other in our careers and different things, and we've touched base on certain things. But I want to say that I appreciate somebody like Mark for his vision, for his passion for space. If you don't have passion for this business, then you need to find something else to do, because I don't know why you're in this business. I appreciate that. But you know what? Just as much, I really appreciate the fact that he's working with children's advocacy organizations. That's something every one of us in this room, particularly me as a parent, can appreciate, and appreciate his efforts in doing that. You don't have a lot of folks that do those kinds of things, and I much appreciate what he's done. You know, after 20 years in NASA and now almost 3 years in the private sector, I want to share with you my views this morning briefly on U.S. government and commercial space in general, and how the two of those go together. Specifically, I'd like to address how a stable, long-term national exploration strategy and policy can provide an environment for commercial endeavors to thrive. I really believe this is the key space policy question for the 21st century, and that's been underlined by the mission you see underway today. How can public policy decisions most effectively spur collateral private development? I mean, that's one of the reasons that NSS is here, is to promote space across the range. It's one of the things I appreciate about the National Space Society is that it supports both sectors in terms of where to go. You know, I got my start in this business. What spurred me on was when I was about 5 years old, I was watching Apollo 17. I remember it to this day on my grainy television set, long before we all remember, well, not all of us, a few of us in the room old enough to remember before remote controls and YouTube, watching that great mission. And I remember that really got me excited. And when I was a kid, between then watching the space shuttle be developed, I snuck out of my junior high classroom to watch Columbia take off in STS-1. I'll never forget that. And that really got me hooked. And from that day on, I was a space geek in terms of what I wanted to do. You know, my last job at NASA was a great job. One of the best jobs I had when I was in NASA, probably the best, running one of the Ares projects teams. We had Ares 1X, we had Ares 1, and we had Ares 5, and we were making great progress on the way to that. And I was a part of that human spaceflight community, trying to move us beyond the space shuttle. But before that, a lot of you probably don't know, I spent a good bit of my time and a good bit of my career in the early days of where NASA was trying to make attempts to move towards more reliance on the commercial sector. That started with the move from the Strategic Defense Initiative Organization, SDIO's DCX. We all remember that vertical lander out in White Sands doing those great tests. We transitioned that over. I was a part of that team, and then getting the first competition up and running, what was called X-33 and the Venture Star. And while that didn't move forward as a lot of us had hoped, it kind of provided the impetus for a lot of the policies that came in later years in terms of where we're going to go. I've always been a strong proponent of a strong commercial base in whatever field it is. I'm a strong conservative by nature, and that just naturally goes along with that. You know, unfortunately, though, for the last 3 or so years, there's been a lot of us versus them. It's been about government or commercial. I think that is entirely counterproductive, and it's very unfortunate that we've gotten to this point. And that leads to a lot of the fighting and the infighting that goes on in this community. You know, as exciting as to space to everyone in this room, and you're not here if you're not a space geek. All right, raise your hand if you're not a space geek. Yeah, I don't think I'm going to see any. All right. You know, we're a small community. As big as today is, and as big as recent missions have been in the last few months, NASA science missions, other commercial missions, this is a very, very, very small sector in the larger part of our economy. We would love for it to all be a bigger sector. Well, if we as a space community can't rally behind each other, support each other's successes, support all sectors of this, then all we do is we circle our wagons and we shoot inward. And that is counterproductive, and that's not what's going to make us successful. Because frankly, when we do that, we make ourselves more irrelevant to the public. In what other field, the other thing that amazes me is, what other field do we have this debate over government versus private sector roles? You know, to me, it's pretty clear. You know, we don't argue about the need for a Navy nor the government to run it. But we also don't want the Navy transporting cruise ship passengers around the country, around the world, unless maybe you're in Italy, which is probably better than the one they had. Excuse me. You know, in reality, though, successful exploration efforts, let's look at historical analogs, have been linked inextricably with commerce. You know, Columbus didn't go to the Queen and say, hey, I want to go check out what's going on out west because, you know, it looks cool and I haven't been out that way. What were they looking for? They were looking for trade routes to the Orient, shorter trade routes. It was a commerce-driven exploration initiative. Lewis and Clark, we think of the grand exploration of the West. If you look at the actual charter that Thomas Jefferson gave them, it says very clearly, for the purposes of commerce. He was looking ahead. It wasn't just wow, these are really pretty streams, and wow, I haven't seen that big of a beaver before. It was about setting up for commerce. So I don't understand why we in the space business have to have this continual debate. To me, this is about the and, not the or, and that's what I want to talk about. So let's talk about first the role of the government, and then I want to talk about the roles of the private sector. You know, in my mind, the fundamental role, number one, of the government, particularly this government, is for the defense, for the common defense of the nation. I don't think anybody debates that. At least they shouldn't debate that in terms of where we want to go. It's pretty clear in our Constitution. Another fundamental role of government, though, is to take on those endeavors that have long-term societal benefit, that are high risk in nature, require significant amounts of upfront capital, but have really, really long payback times. Things that the private sector can't make a business case to do. You know, if you're talking over 5 years, you're going to get squinty-eyed look from folks, and if you're looking at venture capitalists and you're talking more than a couple of years, you get kicked out of the room. That's not what private sector does well. Now, typically, these government projects have been infrastructure projects. For example, the governments underwrote the development of maritime systems around the globe. In this country, the Transcontinental Railroad, which took decades to mature. Early ideas for that started in the 1830s. It wasn't until the late 1860s, and then even after that, it took years for that whole industry to mature, along with government investment. And obviously, most recently, the interstate highway system that Eisenhower started and took decades to put in place as well. But they all opened up the U.S. in their own way. And while the government invested in infrastructure, these things with long-term societal benefits, it's always relied on private companies for the labor to do the job, to get it there, and so there's benefits, and then the support systems that came along the way, from the early wireless stations of Western Union to later on gas stations and hotels. The two have been linked. Space is a logical sector for that reason for U.S. government investment. Space is hard, both technically and economically, to make the case. Now, that said, and as somebody who was in NASA for a couple of decades, few would argue that government programs in and of themselves are fast or efficient, all right? But for the hard things, the things that the private sector won't or can't invest in, well, then that becomes a price that we have to be willing to pay. You know, as much as we would love missile defense to be cheaper, you know, you do what it takes to protect the country, for example. Now, commercial programs, and I've had some very firsthand experience over the last 3 years with them, and I'll give you some examples here in a minute, are by necessity faster paced and more funding constrained. They have to be. They have to be to make the business case close. That said, both sectors can learn from each other, as is clear from NASA's focus today on affordability. You're going to have a panel this afternoon, and I see Gary Lyles in the audience. I think Todd May is going to be here, all good friends of mine from years at NASA, and they're going to be talking about SLS. And if the word affordability doesn't come up at least 3 or 4 times, I'll be shocked. And I know the word beautiful machine is definitely going to come up in terms of that overall arching thing. And you're going to hear what that means. You know, that is not a historic NASA view in terms of things they want to go. Those are things NASA can learn from the other side. Things that the commercial sector can learn from NASA are years of experience, the hard knocks that went through trying to put these things in place. I love Mark's chart with big brother, little brother. I think that's a great way to look at that. Now let's talk about the role of companies. There we go. Private companies can make money by contracting with other entities, i.e. development contracts, selling products, or doing things like creating new wealth, i.e. the lunch speaker today talking about opening up new markets with platinum mining off of asteroids, or others have talked about helium-3 mining. Those are opening new markets. That's not about moving wealth around. It's about creating new wealth, and frankly, that's where we really want to get in the long term. But let's talk about the definitions of commercial for just a minute before we get into this. Commercial, I'm a simple guy. Commercial to me means as a commercial businessman, I have an idea, I get somebody to invest in it, I get the markets to invest in it, I develop it, I take the risk in doing so by doing that, and I bring it to market to sell. If I sell that product, I make money. If I don't sell that product, I lose money. The risk, but yet the reward, is mine as a private entrepreneur in terms of where we go. And I'm amazed when we have to actually have this discussion in this space community. It's not hard. That is the basis of the free enterprise system that has powered this economy for over 200 years, and frankly, the world's economy for many, many years. So what I'd like to do is talk about some of the things that Dynetics is doing in the commercial world. A little bit about Dynetics. Dynetics is an employee-owned company. All 1,300 folks are owners of the company. We're 37 years old. We're based out of Huntsville, Alabama. We got offices around the country. We got our start in the radar business, and we do a lot of that work today in radar engineering. That got into missile engineering. If you've ever heard of the mother of all bombs, or the MOAB, that was our project, and we work on the predecessors to those things. We had a very strong base in DoD programs that we decided to get off into the space business and use to leverage into those kind of worlds, because we think that a lot of the technologies can be common in terms of where we go. So about 3 years ago, Dynetics took its first major foray into the commercial space business with our first commercial satellite called FastSat. Now, FastSat was an interesting model in and of itself. It was a public-private partnership. The partnership, though, was Dynetics supplied the capital to build this satellite. Dynetics wrote the check. Dynetics had engineers and our subcontractors working on this, but we partnered with NASA Marshall Space Flight Center especially, to work on this project because the NASA engineers had great ideas, had good engineering talent, and had facilities we wanted to use. The resource was supplied, the dollars were supplied by Dynetics, and then again, we partnered together to get the engineering done. The result of that partnership, we had a spacecraft ready for flight in 16 months from inception. I mean, somebody's drawing on a table, 2 ready for flight in 16 months. We actually flew 21 months because we were waiting on the launch vehicle, which I'll talk about that problem a little while later, for about 1/3 of the cost and about half the time of other competing systems. That was about bringing the best of both public and private sector together in that kind of a model to go there. Satellite, I'm pleased to say today, has been up and operating for 18 months. We are 50% past our design life, and we intend to keep going probably through, we'd like to get to about double of the design life. We had 3 customers on this mission. We had customers that we had to satisfy. We had 3 Department of Defense program instruments on board. We had 3 NASA instruments on board, including the first nanosat ejection from a microsat, i.e. nanoscale deal. We unfurled a very large solar sail and it went off about its mission. But we had to work with those customers, which had diverging opinions and diverging requirements. And we had government agency representatives like the Aerospace Corporation coming in telling Air Force, they're never going to get there. You know, you should put your instrument on something else. It's not going to happen. I like Mark's chart early on. I think there's a lot of truth to that. There will be a lot of skeptics in terms of what's done. But when you bring the best of both worlds, you're able to do that, and that shows the power of where we go. Now, that satellite is ours. We own it. We own the IP to it, and we're off marketing that to other users. Again, we're marketing. We invested, and now we market it on the open market. The thing I suspect that Paul wanted me to talk about, and I will this morning, is a really exciting activity that we're involved with Paul Allen, who is the co-founder of Microsoft, who announced, as you know, back in December, that he was getting into the launch business, getting into the orbital launch business. Now, Paul is not a stranger to this business. Paul, as you know, funded Burt Rutan to build Spaceship One. So he funded the only effort to put a private human into space. That was a huge, you talk about vision, to be able to do something like that and go after and win the NSAR-X prize after doing that twice. That IP got transferred in, and Virgin is now taking it into Spaceship Two, and hopefully they'll be flying here soon and making money off of those kinds of endeavors. But Paul has a vision, and Paul has seen that the U.S. has clearly been losing its market share, and particularly in commercial space launch, and that there's a market for doing this. So we have a requirement he put out a requirement and put together a team to build a system that could deliver medium lift class satellites to low Earth orbit at about 13,000 pounds of performance and be able to reach a wide array of orbital planes from one base, hence an air-launched approach. Now, we've been air-launching since 1947, but nobody's ever air-launched a 500,000-pound rocket underneath an airplane with 385-foot wingspan. So that makes this quite the challenge, and I'll tell you, one of the most exciting projects I've ever worked on. Paul is putting up his own money for this project. This is not relying on any government funding to go do this. This is purely commercial endeavor. Paul can do that. He sees the vision. He's taking the risk to go off and put that together. The risk is his, and the reward is his. We're pleased to be a member of his team. We're responsible for the overall technical integration of the system. We're also responsible for the hardware. It looks really small on that chart, but it's about 60 feet long. Hardware that holds the launch vehicle to the carrier aircraft and put the whole thing together. We're proud to be partnered with SpaceX, who's building a derivative of the Falcon 9 for the launch vehicle, and with Scale Composites, who's bringing their experience with White Knight 1 and 2 to build the world's largest airplane. As I said earlier, and I'll say it again, it's 385-foot wingspan. So if you go to your favorite football stadium, because, you know, I don't know about you guys, but I'm ready for football, come here soon. So if you lay that on the football field, it would go past the ends of the end zones. It would go off into the seats in terms of what's put together, and about 1.2 million pounds glow. So where are we at on progress with this since the announcement in December? As you can see here on this chart, in the left-hand side, you see the status of the Mojave hangar site. The program has the spacecraft being built out at Mojave on the southwest corner of the field. You can see where the area there is being cleared. Actually, that picture is a little bit old. The steel is coming out in various parts. For those of you who are from that area, you've seen this and you drive by it. You cannot miss it, and when this hangar goes up, you won't miss it, because this will be a very, very large hangar out there. That's both our production hangar and depot-based maintenance hangar for the long term for the aircraft. And also, Stratolaunch has acquired two 747-400s. Those are now in possession. They're going through some testing on the various components. Some are easier just to test on the airplane, but those will be stripped down, because while this looks like two 747s hooked together in the middle, that's not what this is. This is a new all-composite airframe that'll be hand-laid up. We're building one aircraft to start with in that facility. Interestingly enough, the critical path is heavily dependent on that facility getting built, and so that's why it got off and running first. So the Stratolaunch will be stripping those 747 of its critical subsystems, gear, engines, obviously being very, very important on the list, environmental control systems, avionics systems, hydros, things of that nature, and the aluminum shells will get scrapped. In fact, people around the project that are working on this have little pieces of United Airlines things in their offices, from seats to the barf bags to the things that come down out of the ceiling. I've only seen them in movies and when they're demonstrating them to you, but now we've got these souvenirs that are running around the program from taping those things across that you're just not going to need. The program is on a schedule to rapidly move towards a 2017 flight. As you see here on the schedule, SRR has been completed. SDR is underway now, will be complete very shortly, moving off to a preliminary design review in the fall, followed by a critical design review later on next summer, and then we'll start integrated testing out in 2015, and then we'll go through a pretty extensive build-up program on the aircraft, then the aircraft with the launch vehicle attached before we get into flight testing in late 2016, early 2017. So great project. Again, example of private investment, bringing something to market. This is really going after what was the Delta II market. For those of you familiar, that vehicle did very, very well for many years, lifting satellites in that market. And while that's Paul's initial start, his vision is to eventually take crew to space, but he wants to do it on his timetable. Another example that I know everybody in this room is familiar with is Bigelow Aerospace. Mr. Bigelow is funding this effort with his own money. He takes a risk, and he has the resultant award. It's a public-private partnership. He has leveraged ideas and technologies. It was originally the original Transhab for the International Space Station, design work that was done by the folks at Johnson Space Center, transferred that technology over. Dynetics has been pleased to be a part of that team. Many of you know Tim Pickens, and he'll be talking to you later on in this conference a couple times, but Tim Pickens started a company called Orion Propulsion, which Dynetics acquired about 3 years ago when I came on board. And that team built a forward propulsion system for Mr. Bigelow. Again, an all-private endeavor. Putting that whole thing together was an innovative GOX hydrogen system that taps off the ecosystem. That was been delivered and is ready for flight. And then finally, private industry can take advantage of systems developed under contract to NASA, for example, and leverage those from other purposes. This has been done successfully in aerospace projects for many, many decades, particularly in the aeronautics industry. And an arena where this is applicable, for example, is the Space Launch System. SLS is a critical component to future exploration strategy. I am a big believer of heavy lift as a requirement in order to really get us to explore the heavens, both from a human standpoint and from a scientific standpoint in terms of where we want to go. It's the equivalent of building the big tanker to be able to take oil across the country. We need the big tankers for space. Now, NASA is in the process of acquiring risk reductions for advanced boosters. It can be solid, can be liquid, that will allow them to achieve their affordability goals while also increasing performance. Dynetics went in and partnered with Pratt & Whitney Rocketdyne to propose into this effort. Now, this effort in and of itself is commercial, but you'll see my thought here in just a minute. And we're basing this on the venerable Saturn V F1 engine. I cannot wait to see that engine on the test stand and firing and putting out its 1.5 million pounds of thrust again. When we see what that engine did for us the last time around, and our goal is to give NASA obviously the most reliable, affordable, and highest performance booster that they can get while leveraging a proven design. Again, public-private in that sense. But while the prime focus is NASA boosters, at least in the interim, these boosters can be used for other commercial missions. All right, these boosters coupled with upper stages can loft heavy lift, not in the SLS sense of heavy lift, but the classic heavy lift sense, 25 to 30 metric ton kind of range payloads. So this is another case where a government investment may enable in the long term other private markets to be spun off. The bottom line to me is when we keep things simple and we use models and definitions that have been proven in every other market over time, then commercial and U.S. government work in harmony. They don't work against each other in terms of where we go. Now, for this to happen in my mind, a stable space policy is next necessary. Now, when you hear the word policy, you just want to go yawn. I mean, really, before lunch, we want to get into a policy discussion. I promise to keep it short. But it is, I think, critical to where we want to go, because for all of the things we're talking about in this conference, and we've talked about this morning, a stable space policy is absolutely critical. One that transcends politics, which space largely has and should, administrations and Congresses. A stable long-term policy is important to commercial endeavors because it lays out a clear environment in which the market can respond. If by laying out clear goals, clear destinations, and dates, the market can and will respond. It always has. Whether it, again, the Transcon Railroad, other endeavors of that nature, that's what happens. Now, what's interesting is some people say, well, we have a policy, it's commercial space. Well, to my mind, commercial space isn't a policy. Commercial space is an acquisition strategy that's a part of the larger policy in terms of where we want to go. So let's talk about markets, and let's talk about where we may go. While there is undoubtedly great excitement, and should be, around ISS as a market, because it is a market in which money can be made and through cargo and later on crew services, I think we're limiting ourselves to thinking about that. I don't want to be limited to commercial playing in low Earth orbit. I think commercial should go right along as we go and explore the heavens, and there's opportunities to do that. In fact, recent studies have shown that ISS in of itself, just by itself, is not large enough to support a commercial endeavor. So we need to look beyond that. In my opinion, the key to doing that is selecting actual destinations where you can derive economic good, whether it be mining platinum, mining helium-3, whatever you want it to be. You can create new wealth and in parallel require the routine resupply of fuel, provisions, things of that nature where folks can make money. In my mind, we talk about near-Earth objects. To me, the greatest near-Earth object in our backyard is the moon. And the moon is an ideal market for small space companies, for new space companies to get going. The penalty for failure is relatively small. The enterprise risk can be reduced, and ample opportunity to refine the designs through repeated use. And the government could guarantee a market for lunar-based cargo prior to human return, much as we're doing today with the International Space Station, serving as an anchor tenant. That's a great model, I think, for us to learn from ISS and apply to other markets long term. Now, as an example, though, the Google Lunar X Prize was established in 2007 in part to help incentivize the market to enable a commercially funded to the moon to the lunar surface, working to jumpstart a lunar-based economic model. Now, Dynetics jumped in this about 2 years ago, and we formed a team called the Rocket City Space Pioneers. We're one of 29 teams around the globe that are competing for this $30 million prize. I know there's sessions on that here. In fact, there's a Google Lunar symposium that'll follow early next week. This is like Space Week or Space 2 weeks in DC. It's amazing what all's going on here. Again, we take the risk and the reward that comes along with it. And while we've had some successes, you can see on the right-hand side, buying down key risks such as propulsion systems, leveraging things we've done for other commercial and government partners. Getting a rover on the moon, getting out 500 meters, and maybe now 1,000, and taking a high-res video feed and sending it back to Earth, it's not a technical challenge. We can pound the technical challenge flat on this. This is not about technology. It's a market issue. And our business in this particular case depends on ride-sharing to LEO and low lunar orbit. We're going to sell off 90% of our ride-share space off of a Falcon 9. And we can't run a business with stunts, so it has to be able to sustain itself. And it's okay to take risk and develop unique IP, as Burt Rutan and Paul Allen did, and then later transfer it on to Virgin Galactic. But the difference is, though, is those weren't one-shot throwaway systems. Those were meant to go along, whereas it cost $100 million plus. to put something like the Google Prize and actually land in place. So that's why we had to look hard at a ride-sharing model in terms of where we're going to go. A core market issue we've run into, though, this is the effect of policy on commercial space, is that since the moon was eliminated as a primary destination by the U.S. in 2010, and said, well, we may go to the moon, but we might go to an asteroid or eventually want to go to Mars, the dozens of international teams that were planning science and commercial missions to the moon, when you and survey them and talk to them, they'll tell you, hey, our funding's been cut, we're slid to the right, we don't know if we're going to go, and some of them have gone away. So teams are meeting here in D.C. next week to talk about these issues and many related issues in terms of where it goes. The point being here is, if we change directions every few years, the market won't invest. And why would it? Why would we do that with our own money? We wouldn't, in terms of where we want to go. Now, like it or not, I want to use Constellation as an example. Like the program or not, Constellation was designed to implement space policy. And it was articulated and modified and extended by the president, and it was authorized by both a Republican Congress and a Democratic Congress. So there was some transcendence there, but it didn't make it through an administration change. If we're going to be successful in the long term as a community, we need those policies to be able to transcend all of that. It has to be multi-generational or we won't get there. The space science community has done a much better job of doing that over time. We've got to get there in the human spaceflight community, I believe, if we're going to be successful over the long run. There's been some talk lately about, for example, well, but space policy is hard to understand. Well, I don't think it's hard to understand. I mean, I can explain the previous policy in one sentence. The U.S. will meet domestic international commitments by using the space shuttle to finish the ISS, after which the shuttle fleet will be retired and replaced by a new system to support the space station, crew transfer and logistics, enable human lunar return, and sustain lunar presence, and pave the way for future voyages to Mars and near-Earth asteroids. Other important points are captured, other than that one sentence, including, and especially what just enabled what happened today, the COTS program. But that one sentence underscores and really has the essence and policy. So while I am a rocket scientist, and many of you are too, it doesn't take one to write or understand or articulate a clear space policy. And if we can't articulate those policies to the folks that are paying for it, i.e. the taxpayers, then we're not going to get there from here. Finally, it's clear in my mind that if we want to continue the model of successful cooperation off the International Space Station, which has clearly been a great model, a model that brought nations together for peaceful enterprises over the long run, I don't believe it was to save money. I believe clearly the prime benefit was for peaceful enterprise. Then we need to pick a course in this country and stick with it. Been a lot of debate at the Global Exploration Conference this week over what the destinations would be and when they should go. And some countries being very adamant about they feel the moon, for example, should be an early destination. Well, whatever we do, we need to stick with it because we need to stick with our commitments for the long term. The U.S. doesn't want to be known for that. And frankly, we don't want our friends going other places. We want to work with our friends, and that's good for us in the long term from both a economic and a national security standpoint. We don't think about that very often, but I think it's important for us in the long term. In the end, I'm very optimistic about space exploration. If you have to be, you cannot be in this business and not be optimistic. All right, it's a hard business from a lot of perspectives, but you know the successes you have when you have successful missions are what it's all about in terms of where we go. After 25 years in this business, I want to close with my thoughts on what I think it takes to make a successful government and commercial space endeavor. First off is recognizing that it is about the and it's not about the or. It's not about the tyranny of the or. We need to work together as a community and realize that as in many exploration endeavors, the two go hand in hand with where we go. To recognize that the government has a critical role in taking on those things, such as infrastructure, that have no business case, high risk, high capital, and long payoff endeavors. Recognize that a stable long-term space policy and the supporting programs can and will allow the commercial space sector to flourish, and that's what should happen. In my mind, a key to this is picking a destination and laying out a date. If you're really putting together a business plan and you walk in and say, well, I don't know where we're going to go, and I'm not quite sure when they're going to do it, but wow, I've got this really cool technology I want to bring along. You know, you're never going to make it in the door. So as a business person, we need to know what is that long-term plan and where are we going to go? That's very important. While fundamental capabilities are absolutely necessary, heavy lift, deep space exploration craft such as Orion and SLS, Dates and commitments have always been critical to enabling the commercial sector to plan and invest. The Transcontinental Railroad was done on a date, and you knew where it was going to go. I think also you need to recognize that commercial means, simply enough, that the private sector bears the burden of the investment, the resultant risk, and the subsequent reward. This has been the standard of U.S. economic free market system since our founding. I'm a free market capitalist. I believe in that. It's simple, but it's effective. Again, I want to thank Paul for the opportunity to speak here at NSS. Really appreciate the opportunity on this day in particular to give you an idea of my thoughts on space policy and where Dynetics is going. Thank you.
We've got time for one very, very short question. The gentleman in the front row.
Dr. Aldrin.
Did not the Exodus report say that the shuttle would be retired at the end of 2010?
Yes.
So not President Bush say that the shuttle will be retired in 2020?
Yes. So, Dr. Yes.
The implementation of the Constellation program was proposed not the President, but the administration.
Oh, it was bought off by the Constellation program, and of its elements were bought off by the administration and by the Congress specifically. And it went far beyond retiring the space shuttle in 2010. But yes, that was obviously a key element of that. Yeah, the question was, well, he's still going on. All right.
Knowing that the shuttle was going to be retired at the end of 2010, announcing Constellation in January of 2004 gives you 7 years to come up with a replacement. Was it not expected that the Ares 1 would be made by the high reliability of four-segment solids demonstrated after the Challenger accident? And did not the four-segment solids fail to provide sufficient thrust to get Orion into orbit? And we had to shift, the contractor had to shift to five-segment solids, a new rocket. Did not the contractor lie to NASA by saying that Ares 1 could deliver Orion on a four-segment solid?
No. NASA made the architecture decisions with respect to Constellation. That was not decided by the contractor. You're correct. The original baseline out of the ESAS study in 2004 was very clear. The baseline was a four-segment solid with an upper stage powered by the Space Shuttle main engine. However, a business case decision was made in January of 2006, because I was in the middle of that conversation, where we looked at, while four segments were good enough for Ares 1, they were not good enough for heavy lift and Ares 5 in the long term. And so we were going to be making an investment in one and not growing to the other. That a Space Shuttle main engine, while it worked okay as an upper stage engine, it wasn't designed to do that, and it really didn't work very well for an exploration class upper stage engine. So we made the switch to a five-segment J2X based approach. It did add some to the schedule, but it didn't take the schedule to where it went in the end because we didn't get the money that the administration had originally laid out in terms of where it went. So that's where that went, and that's what made sense. There was no lying of anybody that the performance couldn't be met. We could have made the performance work either way. That was not the issue. It was actually a business case perspective.
The original bid for Ares 1 was with the four-segment solid.
There was no bid for Ares 1. NASA was the prime. NASA was the integrator in that particular activity, and we subbed out elements to ATK and
I
3WR.
didn't blame it on ATK. ATK was a participant, a very willing
Well, the prime was NASA, so you can blame NASA if you don't like it, but that's where we ended up.
Okay, the administration of NASA then changed.
We did.
Yeah.
We made it, and I'd stand by that decision from a business case perspective. It wasn't driven by the fact that it couldn't lift Orion. That was a myth that got promulgated in terms of where we went. We were meeting our schedule, and we were under our cost in terms of where we went.
A replacement of the space shuttle in 7 years, did we not?
We didn't start on Aries 1 until 2005.
Well,
So
that's-
didn't
that's
get
not
going.
gonna
And the
replace
original
the
plan was to
shuttle
fly in
retiring in
2012.
2010.
And because the budget didn't happen, the budget got shifted to the right. So I don't know why that's pertinent to what we're talking about today, but that's the facts. All right, thank you.
I'm sure we'll have plenty of time to chat over this at lunch, but Tim would like to present you this as a token of our appreciation with the destinations that we'll be going to.
Outstanding.
Hopefully as a public-private partnership.
Amen.
Thank you very much.
Thank you.
Take a quick photo here. There we are. Thank you.
26, 36